Alrighty, here we are. Boy, there's quite a good group of people here tonight. I see lots of people that we've seen before, a few that we've seen before, and a lot of new ones. Right now, it looks like 17 people. That may be a record for this early in the program. Thank you, one and all. This is probably going to be a really... this may end up splitting into two videos because there's a lot to cover. I have this script here that I put together earlier today, and once I got into it, I realized there's just quite a lot of moving parts when it comes to using the scheduler for science. So before we get into the meat of this, I'd like to just kind of go over some of the scientific things that people are doing with the scheduler now, and also without it with ACP, and just kind of set the stage to the different mission types that might be out there. And if those of you who are watching have another one that you'd like to add, go ahead and put that into the comments stream, and I'll try to respond to that as well. So we have things like asteroid light curves, fast variable stars, exoplanet transits, follow up on transients such as gamma ray bursts, supernovae, novae, CVs, that kind of thing. People study pulsars, and that's kind of tough because the pulse rates can be pretty high, but nonetheless. Long period variable star monitoring, like this Tabby star that people have been monitoring. It's an unusually behaved star, and I know of at least 2 or 3 people who have been taking daily chunks of an hour from it just to keep track of what it's doing, one of them being a guy up at the Great Basin Observatory. Asteroid light curves. Oh, I already said that, didn't I? I've got them in here twice. That would be kind of the vanilla things. Then there's longer period type of work. I just talked to Eric Dose today, and he's not yet using scheduler because he has to set his exposures every night because he's monitoring Myra variables, and they have periods from 150 to 600 days, and so and they can vary over 10 magnitudes, so you just can't put one exposure in. So he has his own very sophisticated lookup table and a system that he uses to build ACP plans. But I talked to him about that, and we're going to see if we can't come up with a way to have scheduler go out and get those exposures at the beginning of the night. So there's a possibility in the future that we could be doing something along those lines. Decaying transients, proper motion studies, all sorts of things, and surveys. I might mention the AAVSO all-sky photometric survey that was done a few years ago, which the data is now in the UCAC4 catalog. That was all done with the scheduler, hands-off 24/7, and they ran it in the southern and northern hemisphere, and it got the Landolt stars and all of the target stars totally automatically. They put it all together, and it just ran autonomously. So something like that really is well suited to the scheduler, because otherwise the planning for that would be unbelievable. And I should probably mention I don't have it in my notes here, but the H-alpha sky survey that's being done by Dennis DeChico and Sean from Sky and Telescope. Anyway, those guys are, David Middleman is the guy who funded it, and he has since passed away, but he left a legacy for that to continue, and they're going to map the entire sky in H-alpha deep with multiple exposures over multiple nights for each part of the sky, and that's also being done with the scheduler. I guess you could argue that might be science. You can certainly derive things from that final image set that would be useful. So some of the advantages of using the scheduler for science would be that if you set things up right, you can relieve yourself of the planning for complicated observing, interleaving things. We'll get into that. But it also has some limitations. The other thing is the scheduler can start and stop itself with weather fluctuations. So if the weather goes unsafe, it can stop and pause a little bit. When it goes safe again, it can go back and pick up where it was And yes, your time series will have a hole in it, but it's unavoidable because during that period, the weather was unsafe. What, did an airplane just fly over here or what? What was that? Oh, well. The limitations on this is there's not a super precise control over sequencing. If you have a high cadence, and we're going to talk about that, you could actually set it all up so that it goes and rips through all night like that, but then you don't need a scheduler at all. So there will be some limitations in sequencing. And complex time series can be a little bit labor intensive to enter, but I'm going to show you how to use the web forms, and you can probably figure out how to do most of what you want to do with that web form. And we'll focus on that. That'll be a big part of what we talk about tonight. And I might mention that if the time series is for 6 hours or 7 hours and your whole night is only 7 hours, why have a scheduler, right? If you're just going to bang, 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 bang all night. So there are some things that don't make sense, but if you have a mixture of people, students, whatever, and they're taking an hour of data here or a couple hours on variable stars, and it's mixed in with other types of science, then it's perfect. So, let's take a look first at the form that we have with ACP. I'm just going to go straight to the form. Which is the one for the image series. And you get to that, the live observing will not be visible if the scheduler is actually running. So this is the form that you'll see, and this is the one to use for science. And so we'll just kind of go through this form and see what's here. There's quite a bit more here than you might think, and there are some subtleties about some of the features, and this is really kind of what I want to get into tonight, is the subtleties, and to help you set up your observing run for doing science, whatever kind of science you want to do. All right, first of all, before we get into it, I want to go back over again, and I do this kind of at the beginning of each one of my videos because it really is key to understanding everything else, and that's to look at the relationship between projects, plans, observations, and image sets. And for that, I will go over here and look at, I don't think I have anything here. Let's just look at one here like this. All right, the project, which would be this, is just a holder for plans. What a plan is the minimum schedulable unit. That's what that's the thing that the scheduler decides whether it can start or not start. So in the case of V5_ONC, all of these things that are here, both of these observations that are under it, this is not a very good example. Let me see what else I can find here. Protostar probably has some good stuff in it. That's yeah, here we go. Okay, well, it's a fairly good one. Let me see if I can find one here, like NEO survey. There we go. Okay. So a plan, for example, this is going to be to look at an asteroid, and the idea is to get 4 images of the asteroid spaced in time. So the plan is the thing that is started by the scheduler, and for the plan to be started, all of the observations, which are the runs in ACP, have to meet their criteria. In this case, it's very simple. The target has to be above 35 degrees horizon. But you can put hour angle constraints, moon avoidance constraints, air mass range, and we will touch on that again later because it's important, and also a repeat count. So given this, and this, all of these, under normal conditions, have to meet the constraints that are there. Otherwise, the scheduler won't start it. So the plan is the minimum schedulable unit. I hope that makes sense. The observation, which is that this is a plan here. Okay. The observations are the runs that are sent to ACP. In this case, for this plan, there are 4 separate ACP runs, and they're separated by, what's this, 45 minutes, 2,400 seconds. So there's that one, and then 45 minutes later, this one's run. 45 minutes later, this one's run. So what this does is it generates 4 ACP runs spaced 45 minutes apart. And then for each one of them, we can look at what images were supposed to be taken for each one. It's probably something simple. Yeah, one 180 second image, one 2-minute image at binning 1 in clear of that field, the field being this. Each one of these ACP runs can be for a different target. As you can see, it has different RA and DEC. But in this one, it's for the same field. And what it's doing is it's going click, coming back 45 minutes later, click, 45 minutes later, click, 45 minutes later, click. Why would you do that? Because you'd come back and you'd blink those images and look for some stuff that's moving in with respect to the stars, namely minor planets, asteroids, comets, whatever. Okay, so that's the relationship between a project, which can have multiple plans. It's just a grouping for you. A plan, which is the minimum schedulable unit. The observation, which is the run that's sent to ACP. And the image set is each series of images that are taken per filter. So if you want to take images in multiple bands, you will put multiple image sets as part of the observation. So if that all makes sense, and please, I'm looking at my chat. I can see it here, which you can too. It's right down here. You can ask me questions and I'll do my best. I've had a few really obscure questions asked in the past, and I've done the best I can. But if it's something, especially where you might be concerned about, or confused, I should say, about this, it's really important to understand that. Okay, so let's go back to our form, because this is really the meat of it all. You may have noticed that I have a project here called Demonstration Plans for Live Video, and it's empty. There's nothing in here. I could put my plan together here, and then within that I could create a plan and go over create observations, but it's just much easier to use this form. So I've already filled it sort of out here. And you can select the projects here. So I've selected my project, or you can create a new one as part of entering this run. You can make a new project and it'll show up over there. So as you might expect, you give the target a name. It has no significance, although you can put in a comet, a minor planet, or a deep sky object and click this and have it calculate the coordinates, or in the case of deep sky coordinates, or in the case of a comet or minor planet, it will bring in the orbital elements, and then those will be calculated whenever it decides to take the image. I should point out the help here. A lot of this information I'm talking about is right here. So don't forget these help buttons. They're all over the place. Okay, so a target, an RA, a DEC, and a position angle. Probably not something you'll use, although it's installed on this system, a rotator. You probably won't use the PA, although you might want to, because mostly that's for rotated guiders. The evil of astronomy, I might add. And the next thing, this is pretty obvious. What do you want in your series? You want to have these images. No, Gordon, no, there's not a variable star name lookup here. That is something that has been asked for, and it would be really great to be able to put in a variable star name here and then click and have it filled in. It is high on my list. It's not going to get into 8.2, but it is high on the list. So it's kind of an obvious thing to do. But thank you. First thing you would do is you'd set up your basic series, but you have some other options here. So you want to put in the block of images that you want. And let's just say I want 2 images in V and 2 images in R, and each of those is at 100 seconds. Oh, let's do some I imaging, 3 images in I, and make that one 50. And you can add more rows here and keep going and add more and more to your basic series. Okay, now we get into the fun stuff. the constraints. Here, and I'm just going to review this because especially for science, the air mass range is important. For photometry, this can force the scheduler to acquire the image within a certain air mass. You can also say it has to be below a certain air mass by putting 1 in here. But so you have that. You can work it either way. The idea behind having the air mass range is, as part of your observations or your jobs that are put into the scheduler, you can have standard stars operating at a higher priority, and when they get into their band of air mass, they'll be acquired, and you can use the data from that to do extinction calculations, for example, using the Hardy method. So that's how the APAS automatic acquisition was able to get both the target stars and all of the Landolt stars that were needed to later reduce that data as all-sky photometry. Of course, you also should be choosing your field locations so that you have not only your target star, but comp stars in there. Obviously, you guys know about that. And I'm not a big expert, so don't ask me complicated questions about doing all-sky photometry, because I would not be able to answer those questions as a rule. But you have these constraints. Again, all of the observations that you put into your plan have to meet this constraint. These constraints you put in here, and they can be different for different observations. And they all have to be met before the scheduler will start the plan. Once it starts the plan, it has made a deal with you that it's going to run it all. But that's a white lie, and we'll get to that later with best efforts. But anyway, as a rule, it's going to run the whole plan, either yes or no. If it can't run any part of it, the whole thing fails. So it's basically a promise by the scheduler to do all of this work as a unit, and keep that in mind. All right, now for the really interesting stuff. The priority, you can use this to shade the priority, and I need to mention that there are 2 ways that you can install the scheduler. You can put all of the users that come in, and let's say you're a department in a school or something. You can put all of the users on the same priority scale, but now you have to trust them not to come in the middle of the night and go, I got to get this data, I'm going to put it in at priority 1,000, and then they block everybody else out. So you have to operate as a team if you're going to use it that way, and everybody has to agree they're going to play fair and not hog the system. Or if they need to hog the system, or if you have some godlike person in your organization that absolutely positively has to have priority over everybody else, you may have to operate it this way. But the default way that this works for priority is everyone operates in their own priority range, and then the scheduler normalizes them into a band of 0 to 1. So I might set up all of my work with priority 1 to 10, and you might set up yours with priority 1 to 100. I don't know why you'd need 100 levels of priority, but let's say, or 1 to 5 or whatever. When it's all over with, it looks at the range of priorities for everything that every user puts in there, gets that range, divides them all, rescales them, and puts everybody on the same scale. So you get to control the priority of your own jobs, but you don't get to push yourself up above anybody else, and you are not able, everybody's on an even keel. So you have those 2 possibilities, but that's a setup option. When you install a scheduler, you get to put that, you get to select that mode. So I should mention that with priority. And depending on how that's set, this little legend down here will say each observer has his own priority scale, or all observers on the same scale, and you'll be able to tell how that's been set up. Now, repeat series. This is important. If you come up here is a image series, 2, 2, 3. That's for 7 images. If I want this entire series, this thing to be repeated over and over and over again, you can put a number in here. I got to go to the real one, not the one over here on my monitor. Okay. As soon as I put something bigger than 1 in here, let's say 4, a new checkbox comes up. So first of all, if you put 4 in here, repeat entire image set this many times. This means that I will get VVRRIII, 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 blah, 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 for a total of 4 loops through this. I hope that makes sense. Now, if I want, I can say separate observation. Now, some more stuff just showed up down here. And by the way, these responsive forms are in 8.2. The functionality is still there, but to have them reveal themselves depending on the mode is new. This just makes it easier for newcomers to understand the effect of the changes. So when I say separate observations, now I have separate observations, as in separate observations here. And what this allows, that means separate ACP jobs. So now each one of those series is going to go to ACP as a separate job. What that means is that the scheduler has the flexibility now to do in between there a periodic autofocus, let's say, or, and we'll talk about this in a little more detail later, somebody could have dumped a new job into this, a new plan into the scheduler that says, now you've got to go do it now. It's high priority. And it could, there's a way for you to put I say high priority. What I really mean is kill everything and go do it, or go do it as the very next thing, or kill everything and go do it. So it will give it a chance to do that. Mainly the monitoring of the weather, which always happens because that happens over in ACP. Forget what I just said about that. But being able to insert a periodic autofocus between each observation is why you might want to divide it up into observations. So if we put one in, let's just say, and I'll show the effect of this. All right, let's just say we put it in as separate observations, but we put the time spacing of 0 and 0 in here. Well, I'm going to back up. All right, we say repeat series 4, and we go ahead and put that request into the system. All right. Now, what we're going to find over here under demonstration plans for live video is our new thing, and it's going to be one observation with a repeat count of 4. Okay. Now, there's a subtle difference. Now, this cannot be interrupted by a periodic autofocus, because it's just one observation. It goes to ACP and it just runs. Once it comes back, then the scheduler gets to look around and decide what else it's going to do, if anything. And there may be something else it can do, and I'll show you how that happens. All right, we're going to go ahead and get rid of this one and come back and change just one thing, call it separate observations. And notice we're still telling it the time spacing is 0 seconds, but separate observations. Okay, let's put that in. Now, we'll come back, refresh this. I don't have an automatic refresher because this is kind of a hard, heavy job to do. Now we have 4 observations. Looky there. And if we look, the first one looks pretty vanilla. The second one, however, there's the time spacing and tolerance are dimmed out, and there's a check mark here after previous, ignore time spacing, and it's forcing this to be back to back. Okay. So now you've given the scheduler a little more flexibility, I'll say. So now we'll go do the next thing, which is to go back, and now we're going to tell it not only do we want separate observations, but we want a time spacing of 1800 seconds. Whoop. Yeah, and let's say 600 seconds slop. And I'll explain this time. Let's explain what this slop is in a minute. Let's go ahead and plug that in. Now we're going to get something like what we had for the asteroid survey, which is we get 4 observations again, but this time it's not back to back. Instead, we have the 1800 second spacing. Now, although, I'm going to repeat this, although the scheduler has started the test target and has committed the time slots for these things, for the 4 observations, there's half-hour gaps in there, so it can come back at the end of the first observation and discover that it can stick other things in there, random targets, up to a point, other time series, but if they're differently spaced, you're going to end up with a moire pattern in time, and they're going to fight each other, and plans are going to fail. And so if you have complex interleaving time series, the scheduler is probably not going to work out well without really, really jumping through hoops. Okay, so I've shown you that there's some subtleties here between selecting separate observations with a 0, which, if they're both zeros, you're going to get immediately after, and the scheduler knows that there's nothing more to do but go bam, right out there and do it again. Okay? Well, the other thing is, by having it redo the observations, it's sending a fresh job to ACP. So if for whatever reason your scope has issues or whatever, and it's going to go back out and it's going to do a pointing update if it needs to assure your target is centered. So that may be another reason you want to divide it up into multiple observations. Now for the fun part. I should mention that even the back-to-back immediately after also does not allow the periodic autofocus. You've got to give it, what did I just say? The 0 time spacing here with the separate obs with 0 time spacing will let the periodic autofocus run. I know I've confused you. I'm really sorry. If you don't use the separate observations and you just put the repeat up here, it won't let the periodic autofocus. But as soon as you divide it into separate observations, it can do that. Okay, so I'm sorry. I really messed that up. Anyway, I hope you understand now what it is. So I'm going to go over here and I have to do my own switching here. So hang on. There we go. And talk about best efforts. This is subtle and sometimes confusing. So what I've made some statements in the past about once it starts the plan, it's either going to finish every single thing or it's going to fail. The plan's going to fail. Well, in a practical sense, you might not know exactly how long it's going to take for something to run, and let's say you think that you've given it an air mass range it'll stay in there for an hour or two, but you don't know how many repeat counts that's going to be, and if you guess wrong, you're either going to come up short and not use all the time you have available, or you're going to run long and the scheduler's going to go, nope, I can't do that because I can't fit it in there. So what you can tell the scheduler to do what's on a let me switch back here. On the form, you can check this best efforts. Now, when you do that, the scheduler it will shift gears, and I'm going to almost read this to you because it says it better than I can. First of all, it doesn't apply to a single observation. So what it lets you do is it lets the scheduler start the first observation without even looking at whether the other ones can meet constraints. That's number one. And number two, it'll start it, even if it doesn't meet constraints, it'll start it, and then it'll run until it falls out of constraints. That's it. So you could put some giant long thing in there, but it really, in practice, it'll only run for an hour. So it'll run for that hour and then fail best constraints, which is successful. And even if there are other observations in there, the plan will still be marked successful because you said, do the best you can. And it's pretty useful. So I'm going to read it again. If a plan is marked best effort, several restrictions are removed. The idea is to start the plan even though it might extend past daylight, or some linked observation would clash in time with another already running plan. And that is interesting because you could have another plan with a bunch of observations, and if this thing starts, let's say you've got some time series with gaps of a half hour and another one with the gaps of 40 minutes, well, eventually they're not going to line up, and there's going to be a clash. And so you can put that in best efforts and it'll go run as much of it as it can, and then if it hits one of these other ones that are already running, it'll just go, okay, I can't do any more. So there's that. As I say, there's a lot of subtleties to this, and it can take you some time to really get the most out of how all this works, but it's turned out to be pretty suited for science, and there's people using it for pretty complicated things. So if a linked observation, that is, one of the observations of the plan, misses its time slot, it has failed that the plan continues to run. If you have one more of these, you should mark them all, one or more of these, you should mark them all best efforts. What that does is it lets the scheduler just start them when it can, and then they just fight it out for the thing, and whichever one clashes with another one, then that's the one that fails. It can become kind of a mess, and when you have a lot of complicated interleaving time series, again, you probably want to just disable the dispatcher and have somebody put together this complicated interleaving thing with whatever as an ACP plan and just run it. So get the most out of your observatory. It's not, the scheduler doesn't solve all the problems in the whole world. If there are any time series that are not marked best efforts mixed in with ones that are, you can almost be guaranteed that one of their observations will miss its time slot, and that series will fail because, as I say, if it's not marked best efforts, the contract between the scheduler and you is, I'm either going to run every single one of these things, or it's going to fail. So that's probably what you want for most cases, is that it promises that it'll do all this work, or otherwise it's not done. So best efforts plan will not fail if an observation encounters an auto-guiding failure. This is another thing. If you use auto-guiding, most science doesn't. Instead, the observation will proceed unguided. This features yet another compromise. The idea is to work through passing clouds. This is really subtle, and this came in a few years ago. Allowing an observation to be bad due to a lack of guiding, yet allowing the plan to continue. If the observation were terminated for guiding failure, the next one might run right away, causing a cascade of observation failures, eventually ending the plan anyway. So by letting it run unguided, you're going to get some bad data while the passing clouds are going by, but it's going to keep running at the speed it would have, and then if there's a gap in the clouds, well, you're going to get data, then the next one. So it's subtle, but if you mark it best efforts, it will let that kind of thing continue. It's kind of interesting. So anybody have any questions about best efforts? It's subtle, and it's really useful for science, especially when you're doing time series. So I'm going to just look at the thing for a minute, and I know maybe somebody's typing. I can't really tell if they're actually typing at this moment. I just know there's 22 people watching, which is pretty good. All right, then onward. The next thing, I already covered the air mass range. Monitor mode. All right, let's go back over here to the form. And we'll close up this constraints here in this series so that we can get this up a little higher on the screen, like this. How about that? All right. So now we have timing and monitor mode. Another area of subtleties that are useful for science. What monitor mode is it says that once you put this plan into the system, if you turn on monitor mode, well, you can go back and turn it on, or you can turn it on before you put it in the system. It's going to rerun the next day it will put it back into play the next day. It doesn't guarantee it's going to run at the same time, although as you'll see, we can make it do that. But normally, it simply acts as though you resubmitted the plan the next day. It puts it into play with all the other plans, and it's going to run when it runs, based on weather variations and things that have been put in, the other plans that have been completed that won't be running the next night. You just don't know. But it will run. It will run within constraints, and it will complete or fail. So that's the contract, as I say. So the monitor mode is really useful. This is what the guys up at Great Basin have been using to monitor Tabby Star. Every night, it takes an hour's worth of data. And there it is. And it shows up in their Dropbox the next day. They don't have to lift a finger. They don't even have to log into the web. It's just there. And every day it produces another batch of data. And totally automatically. And I know there's other people using this for the Tabby Star thing too, and probably other stuff. No news is good news for a software developer, right? If I don't hear from people, that means they're having a good time and they're using their software, and I don't really know what the heck they're doing. I talk to some people when I have problems, and then I ask them what they're doing, and so I learn. But I wish I knew more, and I try to talk to people at the conferences and soak up what I can soak up. And I will say this before I say anything else, the 8.2 release probably has a higher level of user input content than any of the ones before that. And that is especially true of the AutoFlats. There have been some fabulous contributions of ideas and things that have added to the AutoFlat process that have made it more efficient and more powerful. So thank you guys for that. And I do try to take user inputs and ideas and implement them. And Gordon, I'll put the variable star catalog in there. That's a really good one. So getting back to monitor mode. So if you put 1 or 2 or 3 days in here, it's going to requeue every n days forever. All right. Or until must run before. Which makes sense, right? Because must run before means that it'll monitor of all the days before this date. When you put a date in here with monitor mode other than 0, so let's say every 1 day until some 2018 11:20. Oops, I have to put a time in there. Let's see. All right. So it will run every day until this time, and then that's it. It won't monitor anymore. So you have an option of monitoring until you decide to go back in and turn the monitor mode back off or clear the plan out of the system, or it will monitor until a certain date and then just stop itself. And you'll get data up to that point. So that's what monitor mode is. Pretty useful. Now let's take a look at the timing constraints. Here we have must run after and must run before. If I put 201, okay. Let's say let's say 9. If I put dates in here like this, what this means by itself is don't bother to put this plan into play until the 9th at 0000 UTC. Okay? Before that, it'll never become eligible. And it will, it'll put it into play. It'll start becoming eligible on the 9th. And then either it's going to run, or if the system's busy, or if the target maybe is still below the horizon for part of the time, or the weather isn't the skies aren't quite as good, or, the moon, that's a big one. The moon's too bright and you've got a moon avoidance constraint, and it'll try to run it and, well, no, I can't do it tonight. I can't do it tonight. I can't do it tonight either. And then, oops, it's the 20th and I haven't done it yet, well, then it didn't get done. So what you're telling the scheduler is that I want this done, either I want it done starting at this date and not after this date. If you can do it, great. If you can't, don't bother. So the basic timing constraint is that. Now, if I put fixed time in here, come on, hit the right one here. You'll see a couple things just disappeared. And the only thing left is must run after. In this case, what this means is that you're telling the scheduler, come hell or high water, this thing needs to run at this time. So what'll happen is at the beginning of the night, it will look for any of these things and it will start them at the beginning of the night. If they'll meet constraints, it will start it. And that means that come hell or high water, if it can be done, it will be done. And it will be done at that time. Now, I want to say something. Don't use this for minor planets and comets, because you can have the scheduler do the ephemeris for that and run it whenever it needs to, and it'll calculate the ephemeris at that time. So don't put in hard coordinates for a comet, for example. What's that? 49P is the one that's headed our way now, I think. Wertman or whatever it is. Anyway, put it in, and I'll show you in a sec how to do that, and let the scheduler run it when it wants to, and it will do that, and you don't have to nail down the time like that, because then it's stale anyway. The next night you got to put another fixed time in there and another set of coordinates. That's dumb. So just leave the ephemeris calculation to be done at the time imaging starts. So use this for things that have phasing constraints. Exoplanet transit, for example. You could put the time in there, and it'll set this thing up so that it will start some safe time before the exoplanet transit. Now, I got to mention something here. The scheduler will not kill an already running ACP job in order to start one of these things on time. It's not going to do that because it's already started that thing, and it would be, it's going to keep running. It will not kill an already running job. Why would this happen? Why would this miss its time slot? Because there is in ACP itself, in the scheduler itself, and let me bring up the scheduler just briefly so I can show you where this info is. I didn't have this running before, but I will now. And then I think I can just bring it right out here. Yes, okay. In here in the configuration, you can see one area for the ACP sequencer overhead times, and that's these things here. What you're doing with this is you're telling the scheduler how to compute the time that's going to be needed to accomplish a job that's going to send to ACP. It doesn't just simply add up all the image shutter open times. There's slewing overhead, all sorts of stuff. The things that are listed here, if other than the weather latch time, that's a different issue, and I'm not going to even get into that. But the slew speed, rotator speed, that is degrees per second. So if it knows where the rotator is and where it's got to go, it'll figure that out. How long it takes the guider to start up. The download time for images, and of course you'd use bin 1, which is the worst. The processing time, if you're going to do any processing, the time it takes to change filters. You may have a really slow filter wheel. How long does it take to flip? If it has to flip, that's a big deal. And the time for autofocus. So these numbers, when in doubt, make them long. And what you'll end up with is a little more slop in your schedule, maybe a little more idle time, but not, it's not very sensitive. But if you try to be too aggressive with those numbers and you tell it that the overhead is less than what it really is, you may end up with ACP starting a job that'll run long. And if it runs long, it may run long right past one of these fixed time things, in which case that will not start on time. It will get pushed ahead. Well, pushed out in time. So it won't start when it was supposed to. It'll start it as soon as it can without killing anything running in ACP. So that's just something to keep in mind. Other than that, there's some cautions here, and there's a, you can, I got to do it over here. Yeah, that's right. The fly up, the tooltips don't show on this video capture over here, so my apologies. I was trying to show you something, but that does not work. All right. Now, let's think of something even more immediate. Run now. Okay, if I click this, you get a little warning. It'll cause all running plans and any images in process to be immediately terminated, resulting in the current running plan failed. This option is intended for immediate targets of opportunity. So let's say you got a some kind of message, tweet or something about a gamma ray burst, and you want to get on it right away. You can hit run now, and you can see all these timing fields have been dimmed out because they're not applicable anymore. And when you submit this, it will stop what's happening and start it right away. So you can handle targets of opportunity if you need to through this form. And I should mention again, this form is the one that you can see on your tablet, your iPad, your iPhone, or whatever. So you're not limited to a Mac or PC web browser. This works with everything out there. And trust me, it was fun getting it to so that it was compatible with all the browsers, although that has become much, much easier in the last, I'll say, 5 years. Thank goodness. It's and much more capable. With HTML5, it just was a huge improvement. Okay, so I have covered that. There's one more thing I should mention, and for that I'm going to need to bring up the ACP help again here. And I want to point out the engineering white paper that's part of the documentation. By the way, this thing here that I'm showing you is the help that comes with Scheduler, and you can either find it on the Windows Start menu or it shows up in the desktop schedule browser, which I have not shown you on purpose. I will bring that up right now for fun and show this to you. That is this thing. And as you can see, it also shows the plans and all of that. And there are some interesting things you can do with this, and I encourage you to explore it, which include importing ACP plans, which will try to convert them into scheduler things. You can import this remote telescope markup language, but you can also do that on the web form. There is a upload RTML here, so you don't need the desktop schedule browser for that. But the point being here, which is why I brought it out in the first place, help, and then contents brings up this help thing here, this ACP scheduler help. All right, so let me put this thing away real quick. All right. In here is the, for people who might be interested, I've covered this, best efforts plans, and I've also covered the fixed time plans. I didn't refer to this, but I did cover that. You might want to go back and look at this if you're going to use any of these and some other things in here that are what I would call advanced features, but the fixed time plans and the best efforts plans are also listed in here. Okay. So here, if you click here, you'll get a copy of the engineering white paper, which dates back 10 years now, actually 14 years, and has been revised several times. I think I've got the revisions back here. No. Okay, well. So this is one from September 2018, which has a couple of new things in it, and It's the 5th revision, though, so what I wanted to show you in here, besides this gives you some engineering background on how the scheduler works, how its thinking process goes, how it's architected, and the scheduling cycle and all of that. If you're doing complex things, it can help to understand. Some of this is probably more in depth than you want. As Stevie told me a couple of days ago, most people aren't concerned about how the milk gets to market, but if you are, this can help you understand the blood and guts part of it. But I wanted to point out this rising plan delay because in here are a couple of graphs that give you an idea of what it is. For astroimagers, this is a beast because they will typically sit there and micromanage the scheduler and go, well, why isn't my plan starting? Well, the reason it's not starting is that the scheduler is letting it rise. You told it that you can start imaging above 40 degrees elevation, let's say. Well, there's nothing else going on. Why not let it continue to rise and then image it near the meridian where the air is better? Or actually what it does is it measures the centroid of the plan. And so if you have a 2-hour long plan and let's say it's starting down here 4-hour angle, 4 hours, it'll let it drift up until it has the plan is now 2 hours or an hour before, an hour after the meridian, and it'll start at click. It'll image it right across the meridian. So it'll let it drift up until it can start imaging it right there. And the idea here is to take advantage of skies when you can, if you don't have the extra work to do. So the simulation, I don't know whether I can, I can, I can. This is good. All right. So what you see here is a not real busy scheduler doing single images, and it has, what did I say here? This one, I think it's like 30 degrees or something, horizon constraint is all. And it's just randomly scattered stars for the whole night across the sky. Well, you can see it's going to start reaching out to the east as these stars, first it picks up the ones it can that are overhead, and then it starts down, reaching out further east. These are hour angles, right? So with the negative hour angles, it starts reaching further and further and further east. Now I don't have anything rising right now. So now I'm going to come back and pick these ones up here, go back out, pick these up. Oh, here comes some more. It's going to work to the east again. And so basically it's tending to work towards the east because that's when the stars come up, and now it's got a gap in time where it can't get anything to the east. So now it's going to go over and grab these things before they set. So as you can see, it's working not in the best place it could. Now, by turning on rising plan delay and letting the plans rise like that, this really amazed me. This is what happens with it turned on. Everything works right at the meridian, and it's minimized the amount of slew time. It's waiting for stuff to be in the right position. It gets it. It's totally an amazing effect. I never expected it to be like this. I knew it would help. And I will say this came from a customer, a long ago customer who was doing a lot of photometry and he didn't like the fact that it was always grabbing his targets down low when it didn't have to. And John, who was that? He was an ex-Los Alamos scientist. I cannot remember his last name right now. Anyway, thanks to him for this idea, because it's quite remarkable. So when you're learning the scheduler, you might want to turn this off, because if you want to micromanage it, which most people want to do when they first start out, what's happening? I don't know why it's not starting, that kind of thing. Turn it off. Just let it. Or you can go look in the log file and see plan such and such is allowing to rise so much time left before the plan centroid hits the meridian, blah, blah, blah. And it will report to you that it's letting it rise. So, but once you get the confidence in the scheduler and you just let it go and go home and, turn off the computer or whatever and let it run, you're going to come back and find out things ran really well. And your data is being taken at an optimal location in the sky. Unless, of course, you constrain it with the air mass range constraint, in which case it won't be able to do this. It'll have to follow the air mass range and get the target when you told it it has to be acquired. Amazing how the time flies. I just looked and it was only 35 minutes after the hour. Now it's 55 minutes. And, I don't know what to tell you, Dick Berg, but my end here shows that it's cruising right along. So anyway, and John Hoot. Oh, is that Wes Erickson? Is that you? Wow. No, it wasn't John Hoot. John Oliver? No, that's not right either. That was the guy who did the dome geometry calculations that everyone uses at University of Florida, I believe. Anyway, I'll remember his name. Sometime, not now. Anyway, he was a former Los Alamos scientist and lives over in New Mexico to this day. And he's the one who gave me the idea of this. And actually, he was the one who complained, and then I came up with the rising plan delay as the solution. So anyway, I think we've covered it. I'm just going to go over my notes here one more time. Sure enough, rising plan delay is the very last thing. So, yes, it is Wes Erickson. I owe you an email, Wes, and I'm sorry. I saw it this afternoon, and I have not answered it yet, but it's right there at the top of my inbox, so I apologize. Everyone who showed up tonight, we were up to 22 at one point, or 23, and it's still 20, so all of you, and I see Dick jumped off because he was having trouble getting the video, so thank you one and all for coming by. It was really good to see, especially all of you who showed up early and were chit-chatting in the chat stream. It was really, really nice. It makes me feel really good when people are learning stuff out of this. And what I'm actually coming up with is that this is much more effective than the Larry Owings. All right. There he is. I tried to call you this afternoon, by the way, and get your input for this thing, but that's okay. I pretty much know what you're doing anyway. And anyway, Larry's an interesting guy, I might add. So what was I saying? Yes, thank you one and all for coming by and sitting through this. What I'm finding out, or I'm pretty sure I'm finding out, is that this is really effective compared to the written documentation, even though these videos have gone on for like an hour, and each one of them is almost an hour. But I think it's working to get people the fine points of how all this stuff works, and to give people a sort of sense of how things fit together and how to make the best use for what they're doing. And I'm going to keep doing it. And there is on the Comm Center a place where you can, a suggestion box for this channel for what you, excuse me, for what you might want. I'd appreciate it if you have any ideas to drop them in there. And with that, one more very important thing is to be sure. I have to go down here and find I can't find it right now. File Explorer. Oh, there it is. Okay. So, no, I don't want that. I want this. Come on, baby. Firefox. I had it staged for this, but then it gave me an update notice, so I'm not even sure this is going to work. Shouldn't have. No, it's not. Well, so much for that. Yeah, it's broken. So, thank you, Firefox, for not being ready for me when I needed you. Anyway, that subscribe button, click it. if you haven't. And then there's a bell next to it. Click that, and it'll show a little thing around the bell. And if you do that, then the next video you'll get an alert about it. I also send out email a few days ahead of each video, and you should get a YouTube message if you ever go to the channel to see the other videos. Newbie Gordon Spear, the thing I would suggest before you even get into the scheduler, that instead you get the basic ACP running with live plans. And I'm going to show you the ACP help application, or the window for that, quickly. And that would be this thing, ACP help. It's available from the regular ACP console. And I, in there, would go to Getting Started, which is right here. And you're going to be able to see that by using the Help menu in ACP Help Contents. Okay, that's how you get it. And, oops, I just turned off ACP, which means I pulled the rug out from under all my web. Oh, well, we're done anyway. I'll close the browser, and we'll just stick with me. Okay, that's it. This is it. It's gone on an hour now. That's long enough. So thank you one and all for stopping by. I really appreciate it. If you see me looking down, it's because I'm doing my own video switching and reading and that sort of thing. So anyway, thank you again, and we hope to see you in a couple of weeks. Bye-bye.